Hey folks, Kawakchi here. Today I'm starting on a multi-part segment on one of the station's most complex jobs, the scientist. I know I've been singing the praises of exploration and experimentation whilst simultaneously doing the simple entry-level jobs, and I guess that's a bit unfair of me. A bit too much of a, tease move, I guess. But people have asked me in both the comments section and in-game to do a bit on the scientist. I quailed at this because the scientist job is fucking huge. It's actually multiple job roles rolled into one. It used to be split up. Now it's really like 4 departments in one. Deliscience, explosives, chemistry, and I guess you could call it xenoarchaeology? Artifacts, I guess. All of these sub-departments are networked together by the server in the research director's office. This futuristic model of a reel-to-reel computing machine, which can store kilobytes of data using the miracle science of magnetics. With this in mind, the first thing which needs covering is how to use the research department's computer system, as it uses a different OS than the rest of the station's computers. While the station machines usually use ThinkDOS, which is more like, well, DOS, which is suited perfectly to standalone machines, research uses TermOS, which is suited instead for terminal machines which network to a main server, kind of like Unix. This is because research is a lot more of a network than a sea of standalone machines in the way the station is. You've got the server, which interfaces with a bunch of terminals, which in turn interface with a bunch of equipment. I could devote an entire episode to it, but I'm just going to show you enough to figure out the rest yourself. To do this, we're going to learn how to work with the division which uses Dwayne the most, artifact research. Artifact research is usually abandoned, so it's a good place to begin if you're an absolute beginner in the science department. Okay. Things are a bit different in Dwayne. Levels of access are split between regular users who have only write access in their unique home folder and read access everywhere else, and super users who have read-write everywhere. We're going to be mostly sticking to what a regular user's experience is like, though. First, you pop in your ID and type term login. This'll start you off in your unique home directory. To have a look around at what's in your immediate directory, type in ls, short for list. This is pretty much what dir does in ThinkDOS. cd, just think change directory, works in the same way as in ThinkDOS, letting you either specify a full file path, or move to a directory as relating to your current directory. We need to get to the ArtLab tools, so type cd / for now to get into the root directory. Wait, is that a front slash? I've been out of the game too long. I need to talk to more human beings now and then. Anyhow, then type ls again to see what's in the root directory. Now, ArtLab's machines are in the mount directory, so type in cdmnt and then cd artlab. And Beepski has stunned me. Okay, commercial break while I free myself from these cuffs. Okay, that took a bit of doing. Where was I? Okay, we're in ArtLab's folder now. Let's see what's in here. Now, I guess in DOS terms, GPTIO would be like the equivalent of a program, kind of like how you could, back in the days of yore, just type in TIE Fighter in the right directory and get all that 16-bit goodness. So the primer you get when typing in GPTIO is without an argument, covers things pretty thoroughly. Have a look. This gives you pretty much all you need to know about art lab stuff, and it is a great, like, basic section to start off with if you're just learning Dwayne for the first time. Also, typing in help at any time in Dwayne will give you a full command listing in case you want to do things the hard way. You can, basics 1. So first of all, GPTIO info will give you a device's information, like, save the X-ray machine. It'll tell you whether or not it's on, what ID it is, what variables there are, that sort of thing. So let's try it out. Now, to actually see what a variable is set to, you can use the this is tedious. GPTIO peak function, followed by the device ID and then the variable name you're shown in the info screen. Generally speaking, you want to set these as high as you can go so you can burn, crush, or irradiate the artifacts you're testing to maximum effect. So, say, to see the value for X-ray strength, you type in GPTIO peak X-ray rad strength. To change what a variable is set to, you type in the GPTIO poke function, followed by the device ID and a new value you want. So to change that X-ray strength around, you'd go through the same argument with the poke instead of peak function, and then set it to a number. Let's say 2. Nothing will tell you what the possible number range on these variables is, so you're gonna have to experiment. In much the same way, the sense command takes readings from a device, and the read command displays those sensor readings. Let's go through those now. Actually, let's see how high this goes. I have actually, it's been a while. I'm reckoning it's 10. I'm reckoning it does not go beyond 10. Yep. Sky's the limit. Okay. Alright. Let's go through the gamut of different things you can do to artifacts to test for their method of activation now. Before anything, if your artifact is handheld, you want to take it in your hand and have a look at it with the Alt-click function. Take this one, for example. Now, as you can see, you get pretty much no information on it, but if you look at it in this way, and it says it's full of something, then your journey is done before it's begun. It's a beaker artifact, one which is full of a shit ton of saltpeter and a few other exotic chems. So careful not to accidentally spill it. If you're wondering why that one is already activated, it's probably because its activation method is reacting with one of the gases in regular atmosphere. So those just go off at round start, pretty much. Okay, first thing. Drag your artifact over to... let's go left to right. Drag your artifact over to the machine, and then click drag to shove it in. Now, when you click on the machine, it'll display as loaded. Now we head back to the console and type in GPTIO pulse X-ray. Now, there are two types of activation states for these machines. One's activate and one is pulse. You can probably put 2 and 2 together there. Pulse turns it on for a little, and activation turns it on and leaves it on most of the time. That's mostly useful for this machine, the heater plate, because it actually takes a while to heat up, a long while. You have to really fiddle with it. Now, after we've pulsed it like this, even though we didn't hear the artifact go off or activate or anything, we can use those sense and read commands to figure out information unique to each type of machine. Alright, so we found out that even though we bathed it in the highest amount of radiation possible, it has had a weak response. It's tubular, whatever that means. One of the real hardcore science nerds like Floor Pills would probably know that's like a hint towards something. But the special trait section could be a bunch of stuff, like hollow or super dense. And they probably are hints towards something, but I haven't really put 2 and 2 together there. But this one hasn't activated, so let's move on. The heater, as I mentioned, takes a while to spin up, so if you don't mind, I'm going to time-lapse this. Now, as I mentioned, the heater takes a while to spin up. However, once it does, it should change color, becoming reddish, especially if you go into the variables and crank up the heat as far as you can get it. As you can see, the sense and read commands will give us different types of information for each type of machine. In this case, it'll give us different special information about the insides of the artifact and its reaction to high temperatures. You may as well leave the heater on if you're going to be doing a lot of artifact testing, but I've yet to actually determine how much of a drain on power this is. Today it seemed to heat up pretty quickly, so I'm just going to turn it off for now. Now, all of these 3 over here work pretty much the same. So let's finish off this triad. Okay, this one activated. Now, that horrible series of noises highlights pretty much what our artifact is. It is a noise artifact, and it is horrible. It's killing me inside. We're going to turn off the elect box here because I'm pretty sure you can't take out artifacts until it's off. And then even though it's activated, I'm going to show you how the pitcher machine works. I usually use a fire extinguisher in the pitcher because it's big and heavy and metal. But you load it into the pitching component and activate it. Now, we know it didn't work this time because our artifact is already on, but if and when none of these have worked, the next step is to test whether your artifact reacts to any touch chemicals. As there are a metric fuck ton of different chems, we're gonna do the quick and dirty check. So you come into chemistry over here. And you get yourself one of them huge 100U beakers. And what you do is you go down the line here and get as many chems as you can in one shot. And just dump them on it. Now, what you want to be careful of is this last sequence contains both potassium and water, and that equals explosion. So, do the water last. Leave that one in a different beaker. Don't blow up your chem dispensers. Your coworkers will not. They will not find it funny. Okay, after you've hopefully not exploded chemistry, the last test to do is the gas test. So I'm going to take a quick cut here while I get over to where the testing chamber is located on this station. Right. Finally, there is the gas test. Some artifacts respond to different atmospheres. Normally, no one bothers to do this check because it's a bitch and a half. But for starters, we can definitely rule out oxygen and nitrogen, because if either of those was the activator, it would have gone off in normal atmosphere. So we're going to head back into the storage room here and grab something else, like plasma or CO2. What we're also going to grab is a scrubber, because we're going to need to reset the atmosphere to normal after we're done, since we have two different gases to test. Now, make sure you are hooked up to internals, and then set the gas to release. It should fairly quickly begin to fill up the room, since the release pressure is higher than the ambient pressure. There we go. Alright, as we can see, it is not going off. So now you have two options, since it's plasma, to clear it up. Now the regular person option is to turn the scrubber on. It'll begin to scrub the air and return it to normal. And the cooler option, which will probably get the RD mad at you if you're on one of the maps where the test chambers are joined to the station proper, is to just throw a lit match in there and let it burn. The more fun option, to be sure, but, well, it's up to you. Now, we have one more gas left to test, and this gas is, a good little, I don't know, teaching moment or whatever, in terms of getting used to atmosphere if it ain't your bag, because it's a good warning. CO2 despite being a gas which can kill you, is colorless. It will not give you a heads up in the same way plasma will when you release it into the atmosphere. So we're just going to sit here and watch it. The pressure is going to drop down to the same point it was when we opened the plasma can. Only nothing's going to change visually. But if we go over here and flip open an atmosphere analyzer, you'll see that there's plenty of CO2 in the air now. And that's about the basics of the gas test. Okay, one last pointer to wrap up artifact research. Survivability related. Many artifact types are capable of just killing you outright when activated, so it would behoove you to go and get scanned in at cloning before anything. I don't want to spoil all the artifact types, but for the department's sake, I want to mention that one type of large artifact is actually a bomb. Usually a pretty devastating one. Don't worry, it should be pretty obvious that that's what it is when you activate it. The warning messages are pretty explicit. But if that happens, what you want to do is pull the artifact over here. I think every research department has one, but there should be a mass driver with a little button next to it. This is the emergency mass driver for just taking dangerous artifacts like bombs and hurriedly throwing them as far away from the station as you can get them. So what you would do is open this up, move the artifact in, and then punch this button over here. I'm pretty sure that unlike other mass drivers on the station, you actually need to actuate it with a button. It's not going to automatically fire it for you, so remember that when it's crunch time. Okay. The other part I want to cover in this episode is telescience, because it's the other bit that needs a bit of a delicate introduction. But once the basics are learned, the rest can be picked up pretty easily with some time and dedication. Okay. Obligatory heads up. Telescience takes some fairly elementary algebra to do. If you are a brainlet like me, that's fairly intimidating, because it's been quite a long time since you've departed from those halcyon, sepia-toned days of youth. So, fair warning, if high school math freaks you out, skip this. Go hunt for a pre-coded calculator for telescience. They're out there somewhere, I think. They certainly used to be out there. If you're willing to break out the WD-40 and OSFO and start kicking the rust off those long disused brainular gears, though, here we go. The equation for telescience looks like this. B stands for your input. This is the number you punch into the console. T stands for your output. This is the number that is read back to you after you send your test subject, essentially where it comes out. M and B are... Wait, no. Not M and B. M and C are constants for which one must solve. These are different every round, and more importantly, different for every telescience computer. You may hear savvy telescience mans referring to these as offsets. Now, I'm going to walk you through the average telescience endeavor. First, you grab yourself this thing. This is the helmet cam. Technically speaking, it's supposed to be for your intrepid monkey explorer friend here, so you can see where he ends up, but if it's all the same to you, I prefer my teleportation targets to be stationary, so I don't have to try to do math on the fly. You throw this onto the telepad, and then grab this. Research's camera monitor. With this, you can view a couple of other cameras, but the important ones here, the helmet cam. Now, as you can see, there's more than just X and Y coordinates at play here. That's because SS-13 also has Z levels. Depth, you could call it. Kind of like Dwarf Fortress. The Z level determines which map you're on. with the station map Z level, our home, as the lowest one, usually. That's where we have to find before anything. So first off, set your X and Y to 50 each, respectively. And then hit scan. You want to hit scan before you do any action on the telescience machine. It tests whether or not the coordinates you're entering are valid. If you try to use invalid coordinates, fun things may happen, which may get you in trouble with your boss, the RD. Usually the first Z level you try isn't valid, so you move higher and higher in Z numbers until you hit one which shows up as real. There we go. This, in all likelihood, is the station Z level. This is important because one thing that's constant from round to round is that the adventure zone, where all the fun happens, is always one Z level higher than the station, and the debris field, where the mining station is always one Z level above that. So finding the station means you've found the other two, essentially. Now in this case, my y-coordinate is also showing up as invalid, so I'm going to pot these values down a bit. No? Okay. Well, whatever. There we go. Now, as you can see here, we've got a reading of no atmosphere, which means it's a coordinate leading to space, but at least it's a real coordinate, which is what we need. So what we do now is we hit send. And we go look at the helmet cam. It's somewhere. Usually, if you get pretty bog standard coordinates, what you want to do after this is search around a bit and see if you can actually hit the station. But since it's usually a foregone conclusion that the first Z level you hit going up is the station Z level, we're just going to trust it this time. Which may result in explosions, maybe not. So, cancel this and hit receive. We're going to stash the helmet cam away for a little bit. And now you're going to want to start on the fun part, actually solving for the telescience equation. For this, you're going to need 2 GPS units. What I like to do is, since your GPS identifier is limited to 4 characters, I like to name the one we're sending off into space as the away unit. This is the one that goes on the telepad. And the one you're going to keep at home, you can call the home unit. Space GPSs are one of those pieces of kit that, like, I mean, in theory, they're good to have, but in practice, if you have time to pop a distress beacon, you have time to flail around wildly and fight for your life, which you probably want to be doing instead of the former. Okay, so we've got our home and away units, and oh, that's right. Words of wisdom from here on out. Always use the send and receive functions, never the portal function. Yeah, it's cool, and I guess it allows you an expeditious retreat, but unless you've got a damn good reason for it, it's best to save it for emergencies. The portal function uses up titanic amounts of power and can rapidly drain the station if you don't have a robust burn going on in the engine. Not only will this stop your telescience adventures prematurely, but people will most likely not be happy that all the doors and lights are down because you were lazy. So, that's it. Spiel over. Now, take your initial inputs. You've hopefully left them in the computer here, and hit send on the console. Now, open up your home GPS unit and hit refresh on the top. We're looking for here. Yeah, there we go. Our away coordinates. Now, what you want to do is... Well, first of all, you want to note down what Z level is home. And ours is 2. Okay, so that means Z3, Adventure Zone. Z4, Debris Field, hopefully. And we want to note down what our initial inputs are, and then what our outputs are. Now, we just hit receive and yank the away unit back. Now what you do is you change your offsets by 1. Hit scan to make sure it's still valid. And then send the away unit back out. Hit refresh again on the home unit and note down these new values. Okay. Okay. Where was I? Right. Okay, you have these values now, and what you want to do is note the difference between them. Your X value has gone up by 4. So... and your Y value has gone up by 1. Now, these are your values for your M constant. This is what your initial value is multiplied by. So... let's see here. Did I get that right? I got that right. All right. So you want to go back now, and we got our get your GPS back. Don't lose your GPS. Set your coordinates back to their initial value. What you want to do is go in here and try to solve for that one last constant we have missing, the C constant. So take your initial value. 4x, it's 4, or 50, and you want to multiply it by 4. So 50 times 4 equals 200. Now, what popped out the other end is 178. So that means, in all likelihood, what our C constant is going to be is negative 22. I told you I was slow at math. Oh boy. Oh boy. And we do the same thing for our other constant, which is 1. So 100 times 1 is 100. And that's a difference of 81. 81. So all right. So our C constant for X is minus 22, and for Y is minus 81. Now what you want to do is see if you can actually run this in reverse in order to do the normal pastime for telescience, the whole point of telescience, and that is to go to strange Adventure Zone places. And luckily, we have the output coordinates for those already. These Adventure Zone locations are listed here as distress signals. So what we're going to do is we're going to take this first one, NT13. I think that's Meat Station, maybe? I don't know if they're constant or if they're shuffled around. But we're going to try to solve in reverse. So what we do is, okay, you take the coordinates 88, 106, and you're going to set this 1Z level up so you get to the Adventure Zone, and you're going to try to kind of do things in reverse. Okay, so first of all, you want to add 22 to your X value. So that's going to be, what? I'm panicking here. I'm not used to doing these live. Okay, I'm pretty sure that'd be 110. And then what you want to do is divide that by 4. I'm so out of practice with this. Fuck it. Okay, 27.5. So our X value is probably, for our input, is probably 27.5. And for 106, okay, so we're going to add 81 to 106. That equal 187. Yeah, 187. And, of course, divided by 1, that's going to be the 187. So we are going to now try... We're done with the GPS for now, the away unit GPS. We need to go back to the helmet cam, because we want to see where this destination is going to pop out. And we're going to set our coordinates to 27.5. What did I say it was? 187. 187. And we're going to scan. Bingo! It reads an atmosphere. Now, you take your cam viewer here, and you go to the helmet cam view. And then you hit send. Okay, I guess the distress signal codes are shuffled around each round. Okay, this is Lava Land. It is... Don't go to Lava Land unprotected. It is... Like Ice Moon, it is one of those realistically nasty planets in that, like, it's a next level kind of temperature. Like, some places can be so cold that oxygen freezes and stuff. Well, not oxygen, but other gases. It's nasty. But the important thing is, this is our proof of concept. We've got the equation down, we know what the constants are, and now you can go hog wild. Any of these coordinates are now reachable, and thus begins your telescience adventure. And of course, if you're a trader, you could... Boy, the no good you could get up to this. And that's about it. I just took the GPS for the distress signal back home. I'm gonna have to fix that. Okay. You generally want to leave the GPS for the distress signals in place, so you can find your way back if things go wrong. Now, what you want to do if you want to be courteous to your coworkers, which I would recommend being, you never know when you might have to find yourself hollering for dear life, please hit retrieve on the console, please, God! You want to bookmark for them what each location is. You can either use the identifier on the GPS, or more commonly just note it down as the colloquialism for the location. And that's it. Alrighty, that's about it for my first half of my spiel on the scientist role. Next time we'll be covering chemistry and explosives. I know it's been a bit of time since my last release. I'm terribly sorry about that. I was down with a cough for the longest time, and it's rough trying to record salvageable audio when you keep exploding into coughing fits. This time the format was a bit different, which is why the audio may have suffered a little. Normally I'll record voice separately to make it easier to clean up and then stitch footage together as I need it. But as you might imagine, stuff like Dwayne and Telescience meant I kinda had to do it all in one take or not at all. I hope it isn't too bad. In other news, big shout out to Werebore, the SS13 subreddit's resident virtuoso. It's to him I owe thanks for this lovely new outro riff. Pulled me out of a real pickle. Some corporate outfit called Hexacorp's been content claiming my videos, and when I leafed through the legalese on these claims, it seemed like, while they weren't going to take them down, they were going to put ads on them as they pleased. So, if you've been seeing any of those, I'm really sorry. I always wanted this to just be a cool thing I did for the server I've played on for years and years. So if you want to give Werebore a look and spend some time marinating in his silky tones, I'm going to tuck his SoundCloud link in the description. Shine on, you crazy diamond.